welcome. So now we're going to use sine ratio to find missing sides. Right? And other than the fact that we're using different sides, it's going to be exactly the same as when we use tangent. Right? The steps really aren't any different. And why are we using sine? Well, because we're dealing with the hypotenuse. And we can't use tangent to solve for hypotenuse. And we can't use tangent if we're given the hypotenuse, right? Because tangent doesn't use the hypotenuse. Right? So here we want to find A. And if we look at the angle that we're given, A is opposite that angle. Right? It is across the triangle. Right? It's not next to. Right? B is next to that angle. A is opposite because it's on the other side. We're given the hypotenuse. Opposite, and we're given the hypotenuse, it must be sine. All right, so first step is to write the equation. So now it'll be sine, and we always take, so it's the trig function. Oops, I need a little bit more space. All of our equations are going to be the trig function, whether it's sine, cosine, or tangent of an angle. And that's going to equal a ratio. Here, our trig function is sine. Our angle is 56, because that's our angle of reference here. And the ratio for sine, let me just remind us that sine is opposite over hypotenuse. All right, so that's going to be A divided by 24. We want to isolate A, which means we have to multiply both sides by 24 to cancel out that 24. Because all that ratio means that we have A divided by 24. What's the inverse of dividing by 24? Of course, it's multiplying by 24. And if we do it to one side, we've got to do it to the other. So we have 24 sine 56 equals A divided by 24 times 24. This will cancel. So now we have 24 sine 56 equals A. This here is an exact answer. So if you were taking a multiple choice test and that had that as an answer, that would be the exact answer. Right? To find a decimal equivalent, because when somebody asks you how long the side of a triangle is, you probably aren't going to say 24 sine 56. We're going to first use our table, and then we'll use the calculator. Right? So A is going to be equal to 24. We're going to replace sine 56 with a decimal equivalent for the ratio of the sides when we have a 56-degree angle. And it's the ratio of the, in particular, oops, I've lost my, oops, sorry. I cannot find my cursor. Okay. There we go. Guess I just have to hit the smartboard to find it. All right, so we're looking for the ratio, since it's sine, of the opposite and the hypotenuse. And we have this from the last time we did a problem. All right, so that was, I forgot the angle measure. It's like sine. Sine 56, sorry. I have too many things open on my calculator, my computer here. All right, so now we're going to look for a 56-degree angle. I see it right over here. Now we want sine, so that's going to be this value here. So we're going to replace sine 56 with 8.829, right? Because that's going to be the ratio of the opposite to the hypotenuse. 0.829. So that means A is approximately 19.896. Now 24 is the hypotenuse. We're expecting an answer that is less than 24, right? Because the hypotenuse is the largest side in a right triangle. If we get a value larger than 24, then we know we've made a mistake, right? Maybe we hit the wrong number in the calculator, right? Maybe I forgot to, maybe I have my decimal points in the wrong spot, or maybe I missed the decimal point, right? So if you get an answer that's nonsensical, just go back and double check your work, right? Double check plugging into a calculator, right? So we have two ways that we can find a decimal equivalent to our exact answer here, 24 sine 56. One is to use the trig ratio, and the other is to use a calculator. And even with the trig ratio table, we're going to want to use a calculator unless you really want to multiply 24 times 0.829 by hand. Right? Yeah. Fine to use a calculator for that. But we can also just use the calculator and not the table at all to find the answer. And which one is the correct method? Either is fine with me. All right, so in the calculator, I'm simply going to type in sine 56, and in my case, I have to type it in backwards, but I have to do 56 and then sine. And then we're going to multiply that times 24, and that's going to give us our answer. And so let's just pull up that calculator. Oops. There we go. And so we have 56. I know there was a 24 in there. 56 sine. And notice we had 0.829 from the table. Here we just have it taken out to more decimal places. And then we're going to multiply that times 24. So super easy. So we get 19.896, and we'll take it to 4 decimal places, 19.896. I'm sorry, what was the, I forgot the 4th decimal place. $19.8969. There we go. All right, so notice it's exactly the same through 3 decimal places. On that 4th decimal place, it changes a little bit, and that's just because we included more decimal places in our calculation. That's all. This one is a little bit rounded because we rounded this value. So you are going to have a little bit of rounding error when you compute with a rounded value, right? But in the case of we're finding a measurement of a side using a trig ratio, I am fine with either value. Okay, we can have that little bit of rounding error, right? Whether you're using the table or you'll be a little bit more precise if you're using a calculator. But either is fine. So I think I've got 4 problems in this video. All right, so we want to use sine to find a missing side. We're using sine because we know the hypotenuse. Of course, the hypotenuse is opposite the right angle. And we're looking for the opposite. Right? There's no reason to calculate out the other angle in the triangle. Let's just use the angle we're given. That's perfectly good, and that's going to be our reference angle. Right? So when we write our equation, since we are looking for opposite, and we know the hypotenuse, that has to be sine. We take the sine of an angle, and we know sine is equal to opposite, which in this case is y, over hypotenuse, which in this case is 11. All right, so now we need to isolate our variable, so I'll multiply both sides by 11. So we have 11 sine 35 equals y divided by 11 times 11. The 11's cancel. So that gives us y times sine 35 equals y. Of course, 11 times sine 35 is the exact answer. Let's get an approximation by replacing that trig value with the decimal. All right, so y is equal to 11. Let's go to our table, which is hiding on my computer somewhere. And we're looking for 35. And it's got to scroll the table up a little bit. too much. All right, there, now I see it. There's 35 degrees. Sine is the first one there, so 0.574. By the way, the table in your notes is slightly more accurate just because it has one more decimal place. 0.574, right? 0.574. If I plug in the wrong value, it won't be right. All right, let's plug that in. So we have, into a calculator, 11 times 0.574. 6.314. And since the hypotenuse is 11, we're expecting an answer, a number smaller than 11. Right? And then, so now let's use the calculator. Right? So in the calculator, we'll use sine for finding the angle measure. Right? So we're just going to type in 11 times. In this case, I'm going to have to put the trig ratio first because my calculator is backwards. But if you're using a calculator that works forwards, you can just simply type in 11 sine 35, and you will get the answer. I'm going to have to do sine 35 and multiply that times 11. There we go. So we have 35 sine. Notice 0.5735, that would round up to 0.574, and then times 11. Right, so that ratio of the sides never changes, right? It's just that we're going to be multiplying by different things based on what the actual side measures are. And but the ratio won't change because every triangle that has a 35-degree angle is similar. Right? Every right triangle, excuse me, that has that 35-degree angle is going to be similar using angle-angle triangle similarity. That's why the ratio is always the same. What's changing is the size of the triangle, right? When the hypotenuse changes, right, then the length of the opposite side is also going to change. So let's round to 4 decimal places. So this would be 6.3093. 6.3093. And there we go. All right. So our answer is a little bit more precise using the calculator, but either is fine. Right. Notice they're the same to at least 2 decimal place or 1 decimal place. All right. So this problem, we know the opposite side. We're looking for the hypotenuse. Opposite and hypotenuse, it's got to be sine. So we have our equation is going to be, since we have opposite and we're looking for the hypotenuse, the trig ratio we're using is sine. So we take the sine of an angle. Our angle of reference is 20 degrees. So sine 20 equals 15 divided by x. So notice now we have x in the denominator. So we're going to multiply both sides by x to get it out of the denominator. So if we have a constant in the denominator, if we multiply both sides by that constant, our variable is isolated. If we have x in a denominator, we'll multiply both sides by x, and then we're going to divide by the trig function. So in this case, we'll divide by sine 20. So we have x times sine 20 equals 15 divided by x times x. The x's cancel. So now we have x times sine 20 equals 15, but x isn't isolated, so we're going to have to divide by sine 20. So we have x equals 15 divided by sine 20. Let's find out what the ratio is, the value is for a 20-degree angle. What's that ratio? In this case, it's the ratio as a decimal. So let's find our table, which is hiding right probably here. Yep. And, oh, at the very, very top, I see it. 20 degrees. There's sine. All right, so 0.342. No, I already have the calculator value in there. I guess I forgot to take that off. That's okay. I'll write it out. So that's 15 divided by 0.342 is 43 point, and I'm going to round to 3 decimal places. 8. So it's going to be 8596. Tell you what, let's just round to 4 decimal places. 8.8, so 0.8596. If I rounded to 3 decimal places, it would be 0.860. Right, but that's fine. We'll just do 4 decimal places. In the calculator, all right, I'm going to have to do it a little bit backwards. So x is going to be equal to 15 divided by, and I'm going to need parentheses to type in sine 20. If you're using a calculator that works forwards, you won't need those parentheses. There are calculators that work backwards, though. Some of the Casios work backwards. And that's okay. It's not really, just how you have to plug the values in is backwards. And there's my cursor. Because I need to find my calculator. So we have 15 divided by, I want to divide by all of sine 20. So I'm going to need my parentheses first for this calculator. And then 20 sine. Notice that's the 3 decimal places. It's the same trig ratio we got from the table. I'm going to close my parentheses and equals. So now I've got 43.8571. Come on. It's thinking about writing. 8571. There we go. All right, so actually I would have been a little bit more accurate if I rounded to 3 decimal places and put it as 8.88. Well, either way. No, actually, I'm sorry. I'm more accurate if I leave it with 4 decimal places, because if I rounded up, that was going to be 43.86, and 0.8596 is a little closer to 0.8571. Right, and notice the slight difference is that we're calculating with a rounded value in terms of the table. Right, so we're going to have a slight bit of rounding error, but it's just ever so slight. It's not that big a deal. All right, we're going to do one more problem involving sine. We were a little faster in this video because now once you've done one trig ratio, the others aren't too much different. A new playground was built and Sarah was afraid to go down the slide. The slide was 3 meters long and the incline of the slide with the ground was 49 degrees. How high was the slide off the ground to the nearest tenth of a meter? All right, so let's answer that question first. Notice that right here we have well, best I can draw it, a right triangle. Right? We're looking for the height, right? So these are parallel lines, right? This value here is going to be the same as, they're not only parallel, they're congruent, right? Because this is a horizontal line. So this value here is the same as this value here. Right? We're looking for the opposite. We know the hypotenuse. So let's solve for x. So we have, I guess I'll put that over here. This is A. Right, so we have sine 49 because we are looking for the opposite and we know the hypotenuse equals x over 3. We want to isolate our variable, so we'll multiply both sides by 3. So we have 3 sine 49 equals x divided by 3 times 3. The 3's will cancel. So that gives us 3 sine 49 equals x. In this case, let's just use the calculator. Right? Or should we use the table? No, we're going to use the calculator on this one. We won't solve it both ways. Right, so I've got, let me clear that, 49 sine times 3. So the height, it should be less than 3, right, because 3 is the hypotenuse, and it said to round it. We'll write them all out and then we'll round afterwards. Not all of them, but we'll write down 4 decimal places and then we'll round. So we have 2.2641. And to the 1/10 of a meter, x is approximately 2.3 meters. Right? I think to the nearest 1/10 we would have gotten the same answer whether we use the calculator or we use the table. So x is approximately 2.3 meters. Our second question is, what would you change to make Sarah less afraid to go down the slide? So Sarah's afraid, right, because of the height. The height is scaring her. Right? Not the slide in particular, but how high it was. Right? That's what's scaring her. So now, what would change the height of that slide? Right? So the tape's going to pause for a second, and I want your ideas. Right? Just share what you think. Right? There's no wrong answers. We're brainstorming here. Right? So brainstorm what you think would change the height of the slide. What could we do to change the height of the slide? Right? And then we're going to share some of those answers. And I'm going to give you what a possible answer as well. All right? So welcome back. Thank you for sharing your answers. I really appreciate that. All right, so now what could we do to change the incline of this slide? Well, the slide, it was 3 meters, right? Nothing's going to change that 3 meters. But what if we took that slide and brought it down a few notches? So we're still going to have this being 3 feet, but what if it looked more like this? I said not 3 feet, 3 meters. Right? What if we made this distance less? And how could we make that distance less? If we change this angle. Actually, let me write it up here. So if we change the angle of incline, we change the height. Right, so maybe if we change that so maybe this could, so now the slide can go down a bit, right? So I'm of course assuming that we can replace these bars with some smaller bars. So we're keeping the slide at 3 meters. We're just changing this angle of incline. What if we make it smaller? Because remember, shorter sides are opposite smaller angles. Larger sides are opposite larger angles. What if we make it just 20 degrees? Because quite honestly, Sarah here, she looks like a scaredy cat. Let's just make it 20 degrees. So what if it was 20 degrees? Now let's solve for the height. Let's see how the height changes. All right? So we have sine 20 equals h over 3. All right, so we're going to multiply both sides by 3. We see that it's going to be the same steps. So we're going to have 3 sine 20 equals h. Let's use the calculator and find out what the height is now. And by the way, 20 degrees was just an arbitrary length. I could make an arbitrary angle measure. I could change to any angle measure I want. We could really scare her, make it super steep, right? Make that even higher. But if we ever want Sarah to come down the slide, we probably should make that angle a little less. So let's see. We have 20 times sine. So notice the ratio is smaller. So if I multiply 3 by a smaller value, we're going to get a smaller height. So times 3 equals, so now it's only going up 1.026 meters. All right, so now that's not going to be nearly as scary for Sarah. All right, and so now we've solved with tangent, we've solved with sine. Next up, it's cosine. Thanks for watching. Bye for now.